clearing the malignancy.
So this video is going to be about the refeeding effect of insulin spiking and how tumors might benefit that. Also how intermittent fasting and how you break or end the fast can be risky, especially if it's with carbohydrates. So step one is the refeeding spike, insulin plus glucose. Basically, it's amplified when glucose comes back faster after fasting. So the insulin arm is refeeding, then insulin surge, and then STAT3 being upregulated, which is not good. Also what tumors prefer, and tumors exploit this through AKT stabilizing STAT3 phosphorylation. So it seems that dephosphorylating STAT3 could be a good aim or a good target. Also, mTOR or mTORC1 keeps STAT3 transcriptionally active. So mTORC1 is another thing to be targeted at the chromatin DNA level, because if STAT3 can be altered or remodeled at the chromatin DNA level, then this might inhibit this whole tumors taking advantage of glucose after breaking a fast. So tumor cells, they flip back to growth signaling, while immune cells are still in fatty acid mitochondrial mode, because while you're fasting, the body is forced to use fat as a fuel source and not glucose if fats are stored. This is where the real issue lies here, is because glucose acts as a lactate enabler or a lactate arm, because after fasting there's a tumor LDHA spikes, a lactate flood, and that's only with breaking a fast with a glucose. Therefore, lactate export via MCT4, leading to extracellular acidification, because tumors and cancer cells, they thrive in acidic environments. Another problem with abrupt refeeding after fasting, especially with the glucose, is that it actually causes lysosomes to go down, or lysosomes efficiency in being able to oxidize lactate-derived pyruvate efficiently, because lysosomes, they can oxidize lactate during fasting. Therefore, tumors, they don't have lactate, because tumors, they seem to use lactate as a fuel. But if it's broken or ended with rapid glucose refeeding or eating a lot of carbohydrates, that disables the lysosome's ability to be able to oxidize lactate and take lactate away from tumors. Also, lysosomes will acidify instead of detoxifying if a fast is broken with glucose, and acidity supports cancer growth. Okay, this is how STAT3 phosphorylation is enabled, and it's better for STAT3 to be dephosphorylated, but it has to do with IL-6, and when tumors carry or secrete exosomes, these exosomes carry IL-6R fragments, and plus GP130, these insert into recipient immune cell membranes, creating standalone IL-6 signaling modules. How immune cells become STAT3 primed without cytokines. So it sounds like tumors know how to hijack immune cells. That the immune cell supports the phosphorylation of STAT3, or immune cells are STAT3 related, which is not good, because STAT3 is basically what supports cancer cell growth and metastasis and cancer functions. That's why it's better that STAT3 is dephosphorylated. The exosomes, they also load up miRNAs, and what these miRNAs, they suppress STAT5, which is not good because STAT5 is what's supposed to boost the immune system. So cancer cells and tumors, they know how to disable or dismantle the immune system just by suppressing STAT5 as an immune evasion tactic. The way miRNAs are loaded into exosomes is that there are machinery involved. One of the main ones, and I've talked about it in some other videos, is NS-MACE2 or NS-MASE2. Also AGO2, which I haven't spoken about in other videos. Also tetraspanins, which I have talked about in other videos. CD9, CD63, CD81, and then integrins. So basically, exosomal integrins bind ICAM1, VCAM1. This docks exosomes exactly where STAT signaling would normally reset, therefore leading to STAT5 never fully recovering. So that means that tumor exosomes, that they're actually messing with immune cells' ability to activate and recover, or exosomes are literally infiltrating immune system, or exosomes are infiltrating a literal immune cell sites or pathways that are supposed to help immune system to be boosted or activated. So it's pretty much an invasion on the immune system. That reinstates lactate for tumors is STAT3, displacing STAT5 at the DNA chromatin level. The STAT3 recruits a histone deacetylases, DNA methyltransferases. A good way to combat histone deacetylases is with histone deacetylase inhibitors such as Ghee, but too much Ghee can have issues. So what this ends up doing, probably from the histone deacetylases and the DNA methyltransferases recruited by STAT3, is that STAT5 loses chromatin axis. Therefore, STAT5 cannot be upregulated. That actually means a weak immune system. So as a result of STAT5 being closed off from chromatin access, this leads to shunted lactate into pyruvate. Lysosomal oxidation resumes after immune suppression is restored. That means a process will have to be underwent, or have to go and undergo a process to reopen chromatin for STAT5 access. Refeeding, especially with glucose, can backfire because tumors, they can sense insulin signaling. Tumors have instant insulin sensing, so glucose spikes insulin, especially after a fast. So also another issue with refeeding after a fast with glucose is that exosomes will end up being released and delivered because they're already preloaded. The exosome delivery is already in queue. The exosomes are already waiting in line for the insulin signal from the glucose intake. So basically, tumors are they're literally waiting for the signal from the glucose spiking insulin. Also, while STAT5 is suppressed, but not good, because that means because STAT5 boosts the immune system, and but since it's suppressed at the chromatin level because of exosomes, the immune system will not be able to battle and fight against exosome delivery or being released after the tumor senses the insulin spike if a fast is broken or if there's a refeeding with high carbs. And if exosomes are released, they cause their havoc, immune evasion, disabling immune cells, because of immune cells, they won't be able to fight back if the exosomes invade. So it's better to break a fast with like a protein and fruit. So that's it for the video. Like, comment, share, subscribe, and I'll see you in the next video.